Welcome back, folks. In today's video, we're going to cover part 2 of lesson 3.4 of our derivatives of inverse functions. In this video, what we're going to do is look at specifically the derivatives of inverses of trig functions. Okay, kind of building off what we did with the previous parts of the lesson, okay, specifically focusing on the trig here. So here we go. All right, now just like with all our functions, we have rules for finding the derivatives of our inverse trig functions as well. And there's 6 of them. Here they are. Okay, a lot going on the screen, but we're mostly going to focus on the top 3 up here. Okay, sine inverse, cosine inverse, and tangent inverse. If we're good with those, it's very unlikely we're going to see these on the AP exam. Okay, so in class today and then with the homework, tests, quizzes, we'll focus on these top 3 here. And they look a little bit ugly. Let's see here. Let u be a differentiable function of x. Notice each of these have a du over dx in them. Okay, what that just means is that would show how we'd apply the chain rule if our u was something like an x squared or square root x. We'd have to multiply by the derivative of that u. Otherwise, the actual rules aren't too bad. Sine inverse, derivative of sine inverse of u would be 1 over square root 1 minus u squared. And then again, if u is some other function, we'd multiply by its derivative. Cosine inverse is just the negative of that, okay, which kind of matches with our sine and cosine, normal sine and cosine inverses. And then derivative of tangent inverse is just 1 over 1 plus u squared times a du over dx, okay, for whatever this u is here. Now, like usual, we want to think about where these different rules are coming from. So we're going to take a couple minutes and just show you how we'd come up with that rule for the derivative of sine inverse. Okay, so if I have y equals the sine inverse of x, I want to figure out what dy over dx is equal to. Okay, now to do that, I'm actually going to switch this to regular sine form. Okay, if y equals the sine inverse of x, that means that the sine of y is equal to x. And that's literally what my sine inverse means, is if I plug a ratio in here, it's going to give me the angle out. Okay, the angle I plug into the sine function is going to give me the ratio out. So we're just swapping the x's and y's using our definition of a sine inverse here. All right, and what we'll do from there is I'm going to do d over dx of both sides of this. All right, and on the left side, okay, we have something in terms of y, so we're going to have to use implicit differentiation. Okay, the derivative of sine is just cosine. Okay, and then that'll be times dy over dx is equal to the derivative of x is just a 1. All right, and this dy over dx is what we're shooting for. So let's get it by itself. I'm going to divide both sides of this by cosine y. So I have dy over dx is equal to 1 over cosine y. Now, that's not looking too bad, but the issue we have here is notice my expressions in terms of y instead of x. Okay, so what we have here really isn't very helpful yet, but we can clean that up. Wouldn't it be nice to find cosine y in terms of x? I'm going to say we can do that using this relationship that sine y is equal to x. What I'm going to do is I'm going to use a Pythagorean identity. Cosine squared y plus sine squared y is equal to 1. That's something that's been proven for you in a pre-calculus class. Let's get this cosine y by itself here. I'm going to subtract sine squared y from both sides. which is going to leave me with a cosine squared y is equal to 1 minus sine squared y. And this has turned into a mess. That's okay. I want just the cosine of y, so let's take the square root on both sides. Okay, square root, square cancel, so there's my cosine y is equal to square root of 1 minus sine squared y. Alright, so now I have an expression for cosine y, but this sine squared still has a y in it. Okay, the trick here is I'm going to go back up to this original kind of way we rewrote our y equals sine inverse of x. We wrote it as sine of y equals x. Okay, so the sine of y is just x, meaning I can replace this here with just an x squared. Alright, so now I have an expression in terms of x for cosine y. Okay, so here's the final way we have that identity presented as just 1 over square root 1 minus x squared. Alright, so that's why we gave you that rule we did a second ago. And we could prove the other ones, the cosine inverse, the derivatives of tangent inverse, in a similar fashion here. Alright, so let's go ahead and show you how to use those derivatives of our inverse trig functions. Okay, problem 4, part A says find the derivative of tangent inverse of x to the third. Okay, so I've got our derivative rules here. I obviously don't expect to have those memorized 30 seconds after learning them. Like with all our rules though, okay, you're going to want to get these down eventually. Okay, so we're using the tangent rule here obviously. And this rule says our derivative is going to be equal to 1 over 1 plus u squared. So 1 over 1 plus, and in this case our u is whatever function that's inside the tangent inverse. So that would be this x to the third. So that would be x to the third squared. Again, as far as chain rule goes, that's the derivative of my tangent inverse, the derivative of the outside. Here, this du over dx is just reminding us to multiply by the derivative of the inside, this x to the third, which would just be a 3x squared. Alright, so simplifying this down, we'd have a 3x squared across the top, all over 1 plus x to the third squared. Okay, I'd multiply those x components together, an x to the sixth. Alright, so there's my derivative rule. You give me an x value, I'll be able to find you the slope of the tangent line, okay, for that x value for the tangent inverse of x to the third. Let's go ahead and take a look at one more of these together before we give you a few to try on your own. Okay, so same idea, find d over dx, okay, the derivative of this 5 arc sine of 3x. Now first off, arc sine is just the same thing as sine inverse. So if we feel like it, we can rewrite this as d over dx of 5 times the sine inverse of 3x. Alright, AP exam could present it as a sine inverse, could present it as an arc sine, so we'll kind of do the same thing. And then the other thing that's a little bit different about this is notice I do have this 5 out in front. Okay, so it's a little bit overkill, but let's rewrite this by taking that 5 out. We'll write this as 5 times d over dx of sine inverse of the 3x once again. And then things are cleaned up looking just like our derivative rules up top here. This one's utilizing the sine inverse, obviously. So our derivative then is going to be the 5 times 1 over square root of 1 minus the u squared. And in this case, our u, our inner function, is just the 3x. And then we do have to apply our chain rule, the dy over dx, derivative of the 3x, would just be a 3 here. All right, so final answer for this guy, 5 times 3 up top would be 15. All right, all over square root of 1 minus squaring 3x. Squaring the 3 gives us a 9. Squaring the x would just give us an x squared. All right, so there's a few examples of using our derivatives of our trig inverses. Okay, there's also a part C and D to this lesson. So why don't you go ahead, pause the video, give those a shot, and then hit play to check your answer. All right, so there you go, derivatives of our inverse trigonometric functions. The rules look kind of ugly, but when you start using them, problems don't work out too bad. Okay, so go ahead and get working on the homework, finish up that lesson 3.4, and like always, if you need help, let us know. We'll be here to help you out. See you next time.